Here I'm looking at a website that tracks all of the known satellites in orbit around the Earth. Now, when I talk about satellites in this respect, what I mean is any object that has been launched from the Earth and now orbits in some manner around the Earth. Okay, so I'm not necessarily meaning that the satellite is a telescope. I don't necessarily mean that the satellite is a communication satellite or a GPS satellite. It could even be a piece of like space junk, like a leftover piece from a rocket, let's say from one of the Apollo missions. A satellite in this respect is just anything that's orbiting the Earth that we put up there, okay? So every little white speck that you see here on the screen is a satellite that has been launched from the Earth and put up into orbit around the Earth. And you can even click on any one of these dots and it highlights the orbit of that satellite around the Earth. And then up here in the corner, it shows me the perigee. G means Earth. So perigee is the closest approach that this satellite makes to the Earth. Apogee is the furthest approach, the furthest distance that that satellite has around the Earth as it's orbiting. So even though, and I can even rotate this around, even though it looks like the orbit of this particular satellite that I chose at random is very circular, we see that the perigee is smaller than the apogee. That means that this satellite is orbiting around the Earth in an ellipse, although it's an ellipse that's incredibly close to that of a circle, so it doesn't have a very large eccentricity. Remember, the eccentricity is a quantity that describes how ellipse-like is your orbit. The larger the eccentricity, the more stretched out your orbit is, more like that of an ellipse rather than that of a circle. And so I encourage you to play with this website, which I've linked for you, to see in this engagement check, to see if you can find any satellite that has a perfectly circular orbit. I'm sure that that will be really hard to do, if impossible. They'll all have somewhat of a perigee and apogee. That are not exactly the same. Okay, so this particular satellite, the difference between the perigee and apogee is less than 300 kilometers. Now I'm going to go back and we can see a bunch of different populations of satellites. So you see that there's a whole lot of them clustered very close to the Earth's surface. And then there are some of them that are orbiting further out. And we can filter out these satellites in a bunch of different ways. So right now there are, down here at the bottom, we've got 259 known satellites. And I'm going to check the one that says junk, and that highlights them in red. So of those 19,000 satellites, 13,000 of them are considered junk. That means that those satellites are not currently operational, they're not being used. So then that tells us then, if I look at the ones that are not junk, that there are only almost 6,000 satellites orbiting around the Earth right now that are actually being used and are not just like old pieces of technology that are floating around in space in an orbit around the Earth, okay? So there's a big graveyard, it's a big junkyard out there. There's a lot of stuff in orbit around the Earth that is not operational and not useful. You can also filter this by country, so you can see how many satellites the US have launched, how many satellites India has launched, how many satellites Russia has launched. They've launched a lot of them too. US and Russia are the two countries that have the most satellites, either currently operational or, have passed their functional operation date. Reset button brings everything back to normal and clears out all of your filters. Over here where it says presets, I can select from a bunch of different options. I'm going to click the one that says space stations. And so here in red is highlighting the International Space Station. There's only one space station, the International Space Station, where we send astronauts to do experiments and be in orbit around the Earth. The International Space Station, see right here in red is the International Space Station, and you can see that the orbit of the International Space Station is incredibly close to the Earth's surface. In fact, we would consider the International Space Station to be in low Earth orbit. Low Earth orbit is a satellite that's orbiting the Earth at a distance of 2,000 kilometers above the surface or less. So the International Space Station is actually pretty close above us in our sky, at the uppermost part of our Earth's atmosphere, actually. Now, I can also, let's reset that, and take a look at all the all the satellites here in low Earth orbit. You see that the majority of satellites that have been launched so far are in low Earth orbit. 14,000 of them have been in low Earth orbit. You can choose geosynchronous orbit. Geosynchronous satellites are satellites that have the same orbital period as the Earth's rotation. So it takes our Earth 24 hours to rotate once on its axis. Geosynchronous satellites then orbit around the Earth in 24 hours. So in 24 hours, one of these satellites will be able to make one complete trip around the Earth. So basically, they're kind of hovering above a single spot on the Earth's surface. So as the Earth rotates, the satellite will be looking down at the Earth and also rotating at that same rate around on the orbit. Now let's take a look at geostationary orbits. Satellites with geostationary orbits are located at about the same distance away from the Earth as those with geosynchronous orbits, but in particular, to be a geostationary satellite, you are orbiting around the Earth at the Earth's equator. So all of these geostationary spacecraft or satellites are orbiting, see right here, around the Earth directly at its equator. And that's unlike the geosynchronous orbits. Some of them might be orbiting over the equator, but some of them have orbits that are inclined a little bit with respect to the equator. But I wanted to show you these because you had that really nice discussion about the constellation satellites that SpaceX has sent up. These satellites are going to be delivering internet, especially to remote places on the Earth. But because there's so many of these satellites in low Earth orbit, they can reflect the sun's light back toward Earth. And especially for those of us who are doing ground-based astronomy, that streak of those satellites across the sky impact our astronomical observations. So I thought it would be a nice supplement to that for you to actually kind of see where these satellites live in their orbit around the Earth. Those SpaceX Starlink constellation satellites are going to be in low Earth orbit in sort of this halo, very close to the Earth's surface, orbiting at a distance of about 2,000 kilometers above the surface or less. That's what we consider to be a satellite in low Earth orbit.